Okay, in this problem we're going to use the complement of an event to help us determine the probability. And, I think this is a good little problem. So, each of 5 boys randomly chooses a watch from 12 different styles. Okay, we want to know what's the probability that at least 2 boys choose the same type of watch. And we'll express the answer as a decimal rounded to 3 decimal places. Okay, so to calculate this directly would be difficult because, 2 boys could choose the same watch and the others choose different ones. 3 boys could choose the same watch. Again, the other 2 could choose something different. Likewise, 4 boys could choose the same watch, or 5 boys could choose the same watch. So there's lots of different ways that this event could happen where at least 2 boys choose the same type of watch. So the probability that at least 2 choose the same watch, well, we can use the complement, and that's kind of the trick to these types of problems. That's going to be 1 minus the probability of, well, you kind of think about the opposite event. So if it's not true that at least 2 boys choose the same watch, you could say, well, at most 1 boy picks the same watch, and that doesn't really, that's kind of confusing. Equivalently, we could just say, well, if it's not true that at least 2 boys choose the same watch, what happens? Well, if it's not true that at least 2 choose the same watch, it's true, we could say that none choose the same watch. Okay, and this is going to be a much easier event to calculate. Okay, so we've got to set up our fraction here. Well, again, we've got the total number of ways that the watches could be selected in the denominator. Well, again, we've got 5 boys. Well, the first boy, there's 12 ways he could choose a watch. There's also 12 ways that the next boy could choose a watch, etc., for each of the 5 boys. So there's 12 to the 5th ways that these boys could choose a watch. Okay, well, if we want them to choose different watches, okay, so if we want them to choose different watches, or equivalently, they're not going to choose the same watch, well, now we're sampling without replacement, because once somebody picks a watch, we don't want someone else to choose that same watch. So we're counting without replacement. So now I have to think, do I use permutations or combinations? So does the order matter? Would that be a distinct event? And I certainly would say, yes, order does matter. And the reason is they're distinct boys. If I chose a Rolex watch and you chose a what's another watch, a Timex, that's going to be different. That's going to be a different event as if you picked a Rolex watch and I picked the Timex watch, right? Yeah, there was a Rolex and a Timex both picked, but you would probably be happier if you got the Rolex. So definitely the order does matter. So again, this to me, a lot of times deciding this issue, does the order matter or not, that to me is the tricky part. Okay, so we're counting without replacement. Order does matter, so that tells me that we have to use permutations. Okay, so we're going to use our permutation formula in just a second. Again, there's 12 objects to choose from. There's 12 objects, there's 12 watches to pick from. And of those 12 watches, we want to pick 5 different watches, okay, since there's 5 boys. So this is now going to be the computation that we'll have to compute. So again, I think these problems are subtle and difficult. So really take your time and consider this. This is not something where I think a lot of people could just say, oh, well, clearly it's 1 minus blah, 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 all this stuff, okay? So I think probability can be very confusing. So, all right, well, let's go ahead and compute this now. Well, we've got 12 to the 5th in the denominator. Our 12 P5, that'll be 12 factorial divided by 12 minus 5 factorial. I always put little wings on my fraction, just something that I do here. So let's start simplifying. Let's see, we can always calculate 12 to the 5th power here in the denominator. So let's see, 12 to the 5th power. I am getting 12 to the 5th power to be 248,832. 12 factorial divided by, well, the quantity 12 minus 5 factorial. 12 minus 5 will be 7 factorial, and we've seen that you can expand and cancel, so we would be left with a 12 times 11 times 10 times 9 times 8. So 12 times 11 times 10 times 9 times 8. The 7 factorial would cancel the rest of everything out. So let's see, 12 times 11 times 10 times 9 times 8. And again, a lot of calculators have a permutation or combination button. My little calculator that I'm using off to the side doesn't, so I have to just do it all by hand. Alright, so now we're almost there. So let's see, 95,040, if we divide that by 248,832, I'm getting 0.38194444. So let's see, if we take 1 minus that, we'll get 0.618055556 is what I'm getting. So certainly more decimal places than we need, but I'm just jotting them all down here. Let's see, how many places did we want to round to? We wanted to round to 3 decimal places. Okay, so we went to 3 decimal places. If I look at the next digit, since that's less than 5, it says we leave the 8 alone. So it says the probability will be 0.618. Probability will be 0.618 that at least 2 boys choose the same type of watch.